Hello, students, and we're kind of wrapping up everything. This will be our last week. Next week, we'll get online if you have any questions or concerns or anything. So definitely say so. But basically, we're just kind of wrapping up. Is it a washer or disc, or is it a shell method? Now, first of all, I want to make sure you understand that washer disc are really the same thing. A disc is just like a plate. It's solid. It has no holes in it. It just revolves around. It's connected to the X or Y axis, whatever rotating around. And the example I put up here, rotating around the X axis, just because this says revolve around the X axis. Basically, as you can see here, this would be considered a washer because it's not connected. But if this bottom graph wasn't there, this would be a disc. Notice whenever I rotate this around the X axis, it's with respect to X. The shell method, and I try to make something very similar rotating around the X, this would be with respect to Y. Kind of confusing because you want this equation to read X equals, this equation you want it to read Y equals. So definitely pay attention, make sure you know which method. And over here they tell you like it's not possible with any of them. It's only possible with like the volume using both the disk and, well, real quick, the disk, if you can do the disk and you can do the shell method, they're going to give you the same answers if you do it correctly. You're not going to get like a volume with one is one way and volume with another. And real quick, just again, what you should think about this is like area of a circle. It's almost like you're taking a coins and stacking coins on top of coins or plates on top of plates. It's an area of a circle. Pi r squared. Pi r squared. This is a circumference, and basically what it's doing is measuring the circumference around, and this is the height. This is the 2 pi r, the y is the r value, but this f minus, that's a minus, g of x, that's the height. It's almost like you're finding the surface area of a Coke can, just the outside shell, and then you're just doing layers around layers around layers around layers. All right, let's go ahead and take a look at this first problem. And so basically what they're saying there is that this is the shape here, x, y equals x, y equals x to the 1/3. In the first quadrant, do pay attention to that, revolved around the x-axis. And I have made a picture here on Desmos. Here it is. We're not referring to this region, so don't pay attention to that. I don't care. Let's do disk, washer, I don't care which method we're doing. Since the equations already read y equals, I would definitely recommend then just do the disk method. But if you want to turn this, like the second one is easy. If you want to turn this into x equals y to the 3rd power, as you can see, if I turn the blue line on and off, turn the green line on and off there, you can kind of see it's the exact same equation. I don't care which one you use here. I'm actually just going to do the disk method with this one. Since we're doing that, I want to know from what x value to what x value. So it's 0 to 1 because I have to put it with respect to x. Wow. All right, had a little technical difficulties there. So let's go ahead and rotate this. Again, it's going to be integral 0 to 1. I'm going to do a washer method, so it's just going to be dx. Pi r squared, so it's the top one minus the bottom one. And again, if you go back to the graph, you can see which one's which. So x to the 1/3 squared minus x squared. And again, I would just recommend to you, type that into your calculator to get the solution. So it's going to take me longer to type it in. So just like here, 0 to 1, x to the 1/3 squared minus x squared dx. It's thinking, and I get, of course, a weird decimal. Just a sec here, it's approximately 0.266666666 repeating, which is 4/15. There it is, 4/15. And that's what this gives me is 4/15. Just don't forget the pi. And again, you could set up the shell method the same way. I'm going to go ahead and put in there 4/15 I'm going to put the pi on the top. I'm actually going to go ahead and do the shell method just to show you that this still does work. Let me scroll this up a little bit. But again, just remember when you do the shell method, it's going to be with respect to y. So integral 0 to 1 dy. This is going to be 2 pi. Y is, and again, this is kind of like the 2 pi r of the circumference. So now I just got to take top minus bottom, which is going to represent the height of my cylinder as I rotate it around. So I just got to take top minus bottom. Let me go back, look at my picture. Sorry, I forgot which one's which. So the cylinders are going, they're rotating around this way, but the height of them are being measured this way. So it's just going to be top minus bottom, which is red minus blue in this condition. So let me go back, get my pictures up there. I just got to take top minus the bottom one. Oh, instead of x's though, I should have used y minus y third. And again, I can type that easily into the calculator. Let me type that in, 0 to 1, x. I'm just typing x's into the calculator. The calculator doesn't know any difference. To the third power. And again, on this I get 2/15. But I'm not upset because don't forget you're multiplying by 2 pi on this, which would actually end up to be 4/15. 4 pi over 15 anyways. Check my answer, and my answer is perfect. That's really the rest of the homework. They just want you to either choose, like, do you do the disc method, the washer method, or the shell method? And again, disc and washer are technically the same, just one's connected to the axis, one's not connected. It has like a top and bottom layer. It has a hole in the graph. Definitely take your time. If you have any questions or concerns, get a hold of me, and we'll go over the lesson. Thank you.